Hello, in this video we're going to learn about zero and negative exponents. So I'm going to start off with a rule here. For every non-zero number a to the 0 equals 1. So anything to the 0 power equals 1 as long as it wasn't a 0. So I have some examples here for you. So 6 to the 0 power equals 1. Negative 2 to the 0 power equals 1. 6.28 to the 0 power equals 1. And 3/5 to the 0 power equals 1. So obviously anything to the 0 power equals 1. Now, one thing that's going to come up here, if you follow this pattern, 3 to the 0 power equals 1, 2 to the 0 equals 1, and so on. 1 to the 0 equals 1. So 0 to the 0 should equal 1. Okay. Well, let's put that as a question mark right now. The first three are true. Now let's take a look at another set of examples here. We also know that 0 to the third equals 0 because 0 times 0 times 0 equals 0. And 0 squared equals 0. And 0 to the first equals 0, which would mean that 0 to the 0 equals 0. Well, clearly you cannot have these two things being true because they're both different, right? 0 to the 0 can't equal 1 and also 0. And so that's why this says for every non-zero number. So this works for every single number except a base of 0. So those aren't correct, but these are. All right, let's go on to another rule here. This rule, for every non-zero number a, again we have that non-zero clause, and integer n, so some integers, so like 5, 6, 7, 0, negative 2, negative 3. So for every non-zero number a and every integer n, a to the negative n, so we're getting into negative exponents here, equals 1 over a to the n. Okay, so let me show you some examples of that. It seems weird to listen to it as a rule, but the examples make it a little better. So 7 to the third power we know is 7 times 7 times 7. But 7 to the negative third power is 1 over 7 to the third power. Or 1 over 7 times 1 over 7 times 1 over 7. So basically having a negative symbol in the power means reciprocal. Okay, so negative 3 to the negative 2 power is just like the reciprocal of negative 3 squared. You see, 1 over negative 3 squared. So let me show you some examples of that. I had to pause my recording there. I didn't want to scare you all with a sneeze. So here we have 3/5 to the negative 2 power. And I'm going to say that equals 5/3 squared. Okay, so you can see that 3/5 and 5/3 are reciprocals. And so applying this negative exponent just makes it the reciprocal. So why is that true? Well, if we go back to the rule, it says that a to the negative n equals 1 over a to the n. Okay, so we can say that 3/5 to the negative 2 actually is 1 over 3/5 squared, right? By the rule. Well, 1 over just means 1 divided by, right? 1 divided by 3/5 squared. Now, just for the sake of making this easier, I'm going to simplify this 3/5 squared. It's 9 over 25, right? So we actually have 1 divided by 9 over 25. Well, division by fractions is the same as multiplication by the reciprocal. So we end up with 25 over 9, right? Which is this, 25 over 9. And so that's why it just flips it, because actually what you're doing is dividing by the fraction, which means multiplying by the reciprocal. And we're going to get into some more of that later. So let's go on to another example. So here we have an example, 10x squared y to the negative 5th, and we need to simplify this. Now, in order for things with exponents to be simplified, they have to not have negative exponents. Okay, so this is almost there. We have 10x squared is fine, but we can't have y to the negative fifth. Well, remember, when you have all these things next to each other, it just means multiplication. So you can think of them separately, right? So we have that times that, okay, which is, that's multiplication. So we have 10 times x squared times, and this is not y to the fifth, it's 1 over y to the fifth, right? And because of that, we're going to need to just make everything a fraction to make it simpler. So now on the top of this fraction we have 10 times x squared, so 10x squared, and on the bottom we have y to the fifth. And so here's the simplified version of the beginning problem. Alright, let's take a look at 1 over m to the negative 3 power. Again, remember, m to the negative 3 means reciprocal, right? So we have this 1 over, and now it's the reciprocal of m to the negative 3, which is m to the 1 over m to the third, or the reciprocal of m is 1 over m, and then it's just to the third, which is the same as saying 1 divided by 1 over m to the third, which is the same as saying 1 times m to the third over 1. Okay, which means it's m to the third. So that's kind of complicated, so let's go over that again. So we have 1 over, so that's this part, and then m to the negative 3 is the reciprocal, right? Because the rule is m to the negative 3 equals 1 over m to the third. So that's this. And we know that division, or fraction bar, is division. So we have 1 divided by, and then that. Right? It might be easier if I made this blue, right? So here's the blue parts, and then here's the red part. And then we can change that. Once we get to here, it's pretty obvious to go to here because division by fractions, we've been doing that for a while. It's just multiplying by the reciprocal, and now just do the multiplication, you're good to go. So the cool thing here is that once you get this practice and you get this figured out, you realize that anything on the bottom of a fraction that had a negative power goes to the top, right? So this was m to the negative 3 on the bottom, so it becomes m to the third on the top. So wherever, if you have a fraction, wherever the thing is, if it has a positive exponent, it stays there. So if it's on the top with a positive exponent, it stays there. If it's on the bottom with a positive exponent, it stays there. However, if it's on the top with a negative, it moves to the bottom. And then if it's on the bottom with a negative exponent, it moves to the top. So it's kind of easy to figure out that way. Now, if you forget that rule, what's nice is you can just go through the mathematics of it. So let's take a look at this one. So again, I'm going to split this up into 3 different numbers here, because that's what having all these letters smushed together just means multiplication. And so 2 to the negative third is 1 over 2 to the third. X squared is fine as x squared, and z to the negative 7th is 1 over z to the 7th. Alright, now we have the top is x cubed, because everything else is just ones, or sorry, x squared. The bottom, 2 cubed, we can actually simplify that. That's 2 times 2 times 2, which is 8. And then we have this z to the 7th. Okay, so we know we're done because all these exponents are positive, and all the multiplication is done. Let's take a look at this one. So like I said before, if there's a negative exponent on the top of a fraction, this thing's going to move to the bottom. And if it's on the bottom, it's going to move to the top. So what we have here is 7. Then we have x to the 0. That's just going to be 1. So that essentially we can forget about that. It turns into a 1, right? And then this 2 to the negative 1 means it jumps to the top. So that's going to be times 2 to the 1. And then this y to the negative 5th is going to go to the bottom. And this m squared stays where it is because it's already on the bottom and the exponent is positive. So let's take a quick look at this before I continue. So the 7 stays where it is, there's no exponent. The 2, since it had a negative exponent, jumps up to the top, right? And in doing so, loses that negative portion of the exponent. Basically, by applying it, you're jumping it to the top, so you don't write it anymore. And this y had a negative exponent, so that jumps to the bottom. And again, as you apply the negative, it goes away. And then this m had a positive one, so it just stays where it is. Now we can simplify. 2 to the first is 2 times 7 is 14 over, technically these should be in alphabetical order, so I'm just going to write m squared y to the 5th. Evaluate when r equals -3 and x equals 5. Remember, evaluate means replace the variables with numbers and then simplify. So here we have 2 to the -4th, which is going to be 1 over 2 to the 4th. Then we have times r to the 3rd times x to the -2, which is 1 over x squared. Okay, now we can replace everything with numbers. So the r cubed is -3 cubed. So we have 1 over 2 to the 4th times -3 to the 3rd times 1 over, and then x is 5, so 5 squared. Keep in mind the negativity of the base has nothing to do with whether it's on top or bottom. Only the negativity of the exponent does. So even though the base here is negative, it still stays on the top. Okay, so now we're here. So the top is just going to be -3 times -3 times -3, which is -27. The bottom is going to be 2, 4, 8, 16 times 25, which I'm not sure what that is, but I could do 25 times 2 is 50, times 2 is 100, times 2 is 200, times 2 is 400. And so that is the answer. All right. Thanks for watching.